In this section, we're going to study uniformly decelerated rectilinear motion. It is just similar to the UARM, but the only difference is that instead of having the speed increasing at a constant rate or at a constant acceleration, the speed actually decreases at a constant acceleration. So UDRM, when the speed of the body decreases with time, the acceleration is constant, and A, which is delta V over delta T, is negative, since delta V is actually V final minus V initial within the interval of time. So having V final less than V initial, so we have delta V is negative. Time equation motion of not UARM, it's UDRM. A body moves in positive sense with acceleration A, knowing that at t0 equals 0, the body passes by the point m0 of abscissa x0, which is the initial position, with a speed v0, it's the initial speed. Then its position at any instant t is x equal half at squared plus v0 t plus x0. As you can see, it's just the same as that for UARM. Its speed at instant t is v equal at plus v0, but the only difference here is that a is not positive, it's negative. And the relation of v and x at t is v squared minus v0 squared equal 2a into x minus x0. I want to tell you here that this equation could be proved by doing some mathematical calculations and joining the above two equations. I'm not going to go into details. The point here is that this equation is used when time is not known, but we know that it's مثلا UDRM, and we need to find, for example, the speed at a certain position x, knowing the initial speed and the initial position and the acceleration. So this is used when time is not known. So this is a direct relation between the speed and the position. As for the graph, v equal at plus 0, again, this is an equation of a straight line where a is negative, يعني having negative slope, so the graph of v versus t is a decreasing straight line, not an increasing straight line. If v0, if the initial speed is 0, if the body starts from rest, then this is going to be passing through the origin. تكون هيك نازل نزول من هون. This is not required. I don't want you to study the graph of v squared. This graph, not this one, this is required. This is not required. I don't want you to study it now. Example. A particle d moving on a straight line path changes its position according to the time equation x equal minus 0.8 t squared plus 20 t plus 1.3 in SI units. Compare the given time equation to the general form and deduce the type of the particle d. Compare x equal half at squared, it's in the form of x equal half at squared plus v0 t plus x0, where a is negative. See the coefficient of t squared here, the coefficient of t squared is negative. That's why it's considered to be not uniform accelerated rectilinear. This is wrong. The motion is uniformly decelerated rectilinear motion. Give the constant values of v0, a, and x0. By comparison, the coefficient of t here represents the initial speed, which is 20 meters per second. We must be given that the values here are we must be given here that x is in meter and t is in second, so we know that the other parameters are in the SI unit. So v0 is 20 meter per second, and the whole coefficient of t squared is half a. So we say that 0.8 or minus 0.8 is equal to half a. So a is minus 1.6 meter per second square. Doing the calculations, yani multiplying by 2, we get the answer. And x0 is 1.3 meters. Write the speed time equation of the particle d. We said that for UDRM, it's in the form of v equal at plus v0, having a minus 1.6, having v0, the initial speed 20, so v equal minus 1.6 t plus 20. Determine the acceleration, the speed, and the position of d at t equal 2.7. Simply, since it is UDRM, so acceleration is constant, so at any time a is going to be minus 1.6 meter per second squared. This is the instantaneous acceleration.